So let's make sure we're all on the same page. Do you guys know what this symbol here means? What does this symbol here mean? That's right, Aisha. Means the second derivative. Do you know how we find the second derivative? We find the first derivative, and then we find its derivative. That's how you find the second derivative. So let's find the first derivative first. So when I differentiate both sides, the derivative of x squared is going to be 2x. The derivative of y squared, I need the chain rule. So maybe I'll write my little things here. This is power, this is chain, this is constant. Okay. So my derivative is going to be, for the chain rule, it's going to be 2 times something. You keep the inside, which is y, multiplied by the derivative of the inside, which is dy dx. And then the derivative of 16 is just 0. Now I move everything else to the other side. At this point, I realized this was example 1. I could have just jumped to the first derivative. You're going to get negative x over y. That's the first derivative. We did this in example 1. Now I got to calculate the second derivative. So I'm going to take the derivative of both sides. So maybe I'll stretch this out a little bit. I'll say, oh, we're going to do d dx, dy dx, and then a d dx, negative x over y, like this. And when you do that, what do we get? We get the second derivative on the left-hand side. It's like d times d is d squared, and dx times dx is dx squared. And I need the quotient rule for this guy. So the derivative of the top function is -1. You keep the bottom thing, which is y, minus the derivative of the bottom thing is dy dx. And you keep the top thing, which is negative x, all over the bottom squared. Okay. So do you think we're done here, my friends? Or is there maybe something else I should do? Any thoughts? I don't know. I look at
we plug in the negative x over y into the dy over dx.
We do. Excellent. So this is going to equal to negative y plus x, and then we're going to plug in the dy dx, as Aisha says. It's going to be a negative x over y, all divided by y squared. So maybe I should have, maybe I'll take 2 steps to do this, just in case you're half asleep and barely going to make it through the class. Okay. And then this becomes negative y. Sorry, I needed a minus there. So I'm just replacing dy dx with negative x over y. And then I have a negative times a negative times a negative. Overall, that just gives me a negative. So that's going to be negative x squared over y, all divided by y squared. That could be your answer for the second derivative. Is there any questions about that, my friends? All right, cool. So for the last one, this last example here, if you want to find the equation of the tangent line, they give us a point, but I need to find the slope. And the slope is going to basically be dy dx, but I have to evaluate it at a point with both the x coordinate and the y coordinate because our function is implicitly defined. So that's really what I'm trying to find here. Um, a student asks, why don't we cancel this y? I'm not sure what she means by canceling the y. You can multiply top and bottom by y if you want to, if this y here bothers you. So if I did that, then I would have multiply top and bottom by y times y times y. Then your result could look like negative y squared minus x squared all over y cubed. Maybe that looks better to you. This looks kind of ugly. Yeah, that's what you meant. All right, good. Yeah, we could do that. All right. So let's use implicit differentiation to find the slope of the tangent line. So I'm going to use the chain rule first. So that's going to be 3y squared times dy dx. I'm going to use the power rule next. That's 3x squared. And then I got to use the product rule. That's going to be negative 3 times y plus dy dx times negative 3x equal to 0. I'm slightly worried that happened too fast for you. So what just happened? So I'm using the product rule. So this is the negative 3x is the first function, and the second function is the y function. And this is the derivative of the first thing, you keep the second. This is the derivative of the second thing, you keep the first. Okay. Now I want to keep everything involving dy dx on one side, move everything else to the other. So this is going to give me 3y squared dy dx plus, really I could write this as a negative 3x times dy dx equal to, and then we're going to have a 3y, we're going to add 3y to both sides, and a minus 3x squared when I subtract 3x squared from both sides. Once I have that, I can factor out my dy dx, so I get dy dx, I got 3y squared minus 3x equal to 3y minus 3x squared like this. And when I divide both sides, I get dy dx is equal to 3y minus 3x squared divided by 3y squared minus 3x. If you guys look carefully, we could factor out a 3 from the top and the bottom. You get y minus x squared, and you got y squared minus x. And then those 3's can cancel each other out. So, is there any questions? I did this one faster than the others. But now we're just ready to calculate our, plug in the point to get our derivative. So our slope m is just going to be dy dx evaluated at 3 over 2, 3 over 2. So that for us is going to be 3 over 2 minus 9 over 4 divided by 9 over 4 minus 3 over 2. When you look at these guys, you're like, oh, this is like opposites. This actually showed up on your test too, I think, right? This idea of the opposites, you got to factor out a negative 1. So this guy is equal to negative 9 over 4 minus 3 over 2 divided by 9 over 4 minus 3 over 2. And you have the top and the bottom of the same, those guys cancel each other out. And then you end up with a slope of negative 1. So the equation of your line is going to be y minus 3 over 2 is equal to negative 1 times x minus 3 over 2. Gives you y is equal to negative x plus 3 over 2 plus 3 over 2, which gives us y is equal to negative x plus 3. And that's the equation of our tangent line. Okay. So any questions for me? No questions. If you don't mind, I want to show you a graph of this situation. So I'm going to go to Desmos. I'm going to graph these two equations, and then you can see kind of visually what's going on. And then we'll end class, obviously. So let's open up Desmos real quick here. The first equation we had was y to the third power plus x to the third power minus 3xy equal to 0. So that's what our equation looks like. And then the equation of our line was y is equal to negative x plus 3. And the point that we care about was 3 divided by 2, comma, 3 divided by 2. So I hope you guys can see that we have our curve, and then that blue line was the tangent line that we just found. It's kind of cool, right? Looks cool. All right, everybody. You all take care and have a great weekend, okay? 2.7 video by Monday. Thank you. Take care.
Professor.
No worries. Bye.
Thank you, Professor. Have a good day.
You too. You too.
Thank you.
You're welcome.